Let's take a look at another special feature of a triangle. It's called the median of a triangle. A median of a triangle is a segment whose endpoints are a vertex of a triangle and the midpoint of the opposite side. Well, here's one that's drawn from C, vertex, to the midpoint of the opposite side. A triangle has three medians, and they all intersect at one point inside the triangle. Now, there's a special name for that point of concurrency of those three medians. It's called the centroid of the triangle. There's a special theorem about the centroid. When you have all three medians, here's one median, goes from this vertex to the midpoint. Notice these two segments are equal. When you have median line segment BC, when you have this median, segment AY, this median, segment CX, notice they are intersecting at point P. This point is called the centroid. Now, according to the centroid theorem, the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. Well, another way to say that is this distance AP, the measure of this segment, AP, is equal to 2/3 of the median AY. Same thing here. BP is equal to 2/3 of BZ. And another one, CP is equal to 2/3 of CX. Now, in addition to being called the centroid, we can also call this point the center of gravity. And that simply means that this is a point that would be equal, that would balance this triangular region. In other words, if we had an object in the shape of a triangle and we wanted to balance it, if we found the centroid, that would be the balance of that region. We could actually balance that triangle or that triangular region. Now, knowing these things about the median, let's see if we can solve some problems. We have a triangle, and notice we have three medians that have been drawn. Median line segment AF, median line segment BD, and we also have CE, line segment CE. Where are they meeting? At point G, which is called the centroid. Now suppose in this triangle, we're given that line segment, or AF, is equal to 12. Okay? Let's see if we can first find AG. We're looking for AG. We know that AF is equal to 12. What is AG equal to? All right. Well, remember the centroid theorem that AG is equal to 2/3 of what? AF. Okay? But we know AF. We know AF is equal to 12. So what I'll just simply do is substitute in place of AF, 12. And what is 2/3 of 12? It's 8. So AG is equal to 8 because AF is equal to 12. And that does verify our centroid theorem that AG is equal to 2/3 of AF. Okay? Let's try another one. Same figure. This time we're being asked to find what CE is. Here's CE. This whole segment, this whole median. What's the measure of CE? All right, let's keep that in mind. We're also given that GE, this little distance right here, is equal to 4 8/10. What is CE? All right, that's what we're trying to find. But you know, do you remember that segment addition postulate? That CE is equal to, this whole segment, the measure of this segment, is equal to CG plus GE. Remember that? This is called the segment addition postulate. You can add these two measures and get the measure of the entire segment. We also know that from the centroid theorem that CG, right here, is equal to 2/3 of what? CE. Okay? Well, we got two things to work with. Now remember, what are we trying to find? We're trying to find CE. Let's keep that in mind. We have two equations to work with. Now, we're given that what? GE is equal to 4 8/10. Well, what I'm going to do is, I'm going to take that equation, I'm going to rewrite it, but this time, I'm going to come over here, I'm going to substitute, I'm going to take this equation right here, and I'm going to substitute in place of GE 4 8/10. So CE is equal to CG plus 4 8/10. Okay. I also see something else. What's CG equal to? This right here. And I have that in my equation. That's equal to 2/3 CE. So I'm going to write CE is equal to, I'm going to substitute 2/3 CE for CG. Plus 4 8/10. Well, let's look at this. I have CE equals 2/3 CE plus 4 8/10. I can combine my CE's. Remember, there's a 1 there. So what do we have? Let's subtract 2/3 CE from both sides. And when we subtract, we get 1/3 CE is equal to 4 8/10. We're trying to find CE right here. What do we do here? We multiply both sides by 3. And when we multiply both sides by 3, we get CE is equal to, and I've gone ahead and multiplied, 3 times 4 8/10 is equal to 14 4/10. So that's what CE is equal to. And that sounds pretty reasonable, because if this is 4 8/10, CE is 3 times that amount, which is 14 4/10.